Okay, this is a tough thing for me to have to do with the beaten tree. Which beaten tree?
Hello. Today I'm going to start a new series aimed at
Look at
A-level students of physics. Today we're going to solve the Schrödinger equation in England for a free taken by those students aged 16 to 18 just before they leave school and go on to college or university.
Witchcraft. Hoodoo voodoo.
Today we're going to look at classical mechanics, which covers all of these items listed here. It is called classical mechanics because it doesn't take into account Einstein's theories of relativity. First, we look at Newton's laws of motion. The first law says that an object will continue in its state of rest or uniform motion unless acted upon by an external force. What that means is that if there is an object at rest, then it will stay at rest forevermore unless there is a force that comes along and causes it to move. Alternatively, if a body is travelling through space at, say, 20 miles an hour, then it will continue to travel at 20 miles an hour for the rest of eternity through space in a straight line without deviating and without the need for any more energy or power to do so.
Well, we're trying to figure out what is the electron,
now this seems at first
the
sight
photon,
to be
the
contrary
positron,
to our experience on Earth,
it's
because
coming
if,
at
for
this
example,
this
you
way,
roll a
this way.
ball along the surface of the Earth, eventually it slows down and stops. And the reason for that, of course, is that it is going through air, and there's some turbulence in the air, which creates a force that slows the ball down.
We don't know any of what
and of course,
it is
there's
yet, but there
friction
it
with
is.
the ground, which creates a force and slows the ball down. So we are used to things slowing
We
down.
listen to classic mechanics in
according
the
to
background,
Newton,
like
if there are no
Mozart hitting the
forces,
key.
then it won't slow down. It will continue forevermore without any additional power. Newton's second law follows on from this by saying that if you do want to change the speed of something, then you have to apply a force. And this gives us one of the most common equations that we will find. F equals ma. F is the force, m is the mass, and a is the acceleration. It says if you want to change the velocity, which a change of velocity is acceleration, if you want to change the velocity of the mass, you have to apply a force which is equal to the mass times the acceleration. If we look at the units of this, we would say that the units of force are mass, which is of course kilograms, times acceleration, which is meters per second squared. But that's a rather clumsy form of units, so that is usually replaced by the units called the Newton. Force is expressed in newtons. Newton's third law is commonly expressed as to every action there is an equal and opposite reaction, which means that if I lean against a wall and exert a force on that wall, the force exerts an equal and opposite force on me. When I stand on the ground, I exert a force on the earth. And the force and the earth exerts an equal and opposite force on me. In other words, the force by body 1 on body 2 is equal to the force by body 2 on body 1.
My point being, please come and talk to someone.
We're going to look at a couple of definitions. First, we're going to define velocity as the distance, which we usually represent by the letter S,
People put you in here
divided
before.
by time. If you travel 60 miles
The limits.
in
When you
1
put somebody
hour,
in there like that,
then you can say that
you
your
might
velocity
alter that the
is
equation
60
value here is wrong,
miles
but
per
the truth of the
hour.
matter is
What is the difference
photons
between
on
velocity
this
and
data
a speed?
compression.
Well,
Okay,
velocity
we're going to run primarily a paperless
is a
subject.
vector,
That's why the website
and
is
a
there.
vector